Hey guys, in this video I'm going to show you how to program a PID Control MyBlock, how to use it with the gyro sensor to drive straight, and how to use it with the color sensor for line following. PID stands for Proportional, Integral, and Derivative. Having the PID Control MyBlock makes it easier to use PID Control in other programs.
The PID Control MyBlock is usually called inside of a loop. It has 5 inputs. N is the loop number, error is the difference between the desired value and the actual value, like the error in the robot's angle when driving straight. Kp is the gain for proportional control. Ki is the gain for integral control. And Kd is the gain for derivative control. The integral is the sum of the errors from all the loops. It is calculated by adding the current error to the integral from the prior loop. The derivative is the change in the error. It is calculated by subtracting the prior loop's error from the current error. The PID control output is the sum of 3 parts. The proportional part is Kp times the error. The integral part is Ki times the integral. And the derivative part is Kd times the derivative.
Now we'll program the PID Control algorithm.
We start by defining the MyBlock inputs: loop number, error, Kp, Ki, and Kd. A switch block is used to check if the loop number is 0. If it is, then the integral and the prior loop's error are set to 0. The switch block default needs to be set to 1. A math block adds the integral from the last loop to the current error to calculate the integral. Another math block subtracts the prior loop's error from the current error to calculate the derivative. Now we'll calculate the PID control output. We multiply Kp times the error. Then we multiply Ki times the integral, and then Kd times the derivative. We use an advanced math block to add the proportional, integral, and derivative parts to calculate the output. We change the equation of the math block to a plus b plus c plus d. The error is copied to the error last variable to be used in the next loop.
Now we'll make the PID Control MyBlock.
We shrink down the program so that we can select it. In the Tools menu, we select MyBlock Builder and the MyBlock Builder window pops up. I'll name the MyBlock PID Control and give it a thinking head icon. There are 5 inputs and 1 output, so I'll make those now. The first input is the loop number, with default value of 0 and an N icon. The error has default value of 0 and an hashtag icon. Kp has a default value of 0.01 and an X icon. Ki has a default value of 0 and an X1 icon. Kd has a default value of 0 and an X2 icon. I'll name the output PID, specify that it is an output, and give it a C icon for command. Now when I select Finish, the MyBlock is created. Now we connect the inputs to our input variables. We also connect the command to the output.
Now let's use the PID Control MyBlock with the gyro sensor to drive straight. Here's our robot and the gyro sensor attached next to the brick.
For the straight drive program, I'll get a loop and put the PID Control MyBlock in it. A wire connects the loop number from the loop to the loop number input. The robot angle is measured using the gyro sensor. Our gyro sensor is connected to port 2. A math block calculates the error by subtracting the gyro angle from the desired angle, which I'll set to 0. The error is the second input to the MyBlock. I'll add a move steering block in the on mode and with a power of 40. We'll have the robot drive for 5 rotations of motor B. The angle is the output of the PID Control MyBlock.
Let's try it, but first let's see what happens with no PID control.
I'll set KP, KI, and KD to 0. The gyro angle is shown in port 2 of the port view below the canvas. We'll see how the angle changes as the robot drives. The robot looked like it went in a straight line, but we can see from reading the gyro sensor value that it ended up at 10 degrees.
Now I'll run it with PID control.
I'll set KP to 1, KI to 0.01, and KD to 1. This time the robot is driving with almost no error. It ends up with an angle error of -1 degrees.
Now let's use the PID Control MyBlock to follow a line using the color sensor. Here's our color sensor attached at the front of our robot.
The sensor projects light onto the surface. The reflected light intensity is measured and can be seen in port 3 of the port view. For the line follower program, I'll copy the straight drive program and change it from reading the gyro sensor to reading the color sensor on the mode reflected light intensity. I'll make the desired light intensity 50. First, the robot will follow the line using only proportional control, so I'll set the KP gain to 0.65 and the KI and KD to 0. And I'll change the power to 20. The robot will stop after 3 wheel rotations. The robot is following the line, but weaving back and forth across the line. I'll add a derivative KD gain of 6 and run it again. Now the robot follows the line smoothly.
The correct PID control gains will be different for different robots and programs, so you'll need to do a lot of testing with different gains for your robot. We have separate videos for specialized MyBlocks for driving straight and line following with PID control, so I hope you have time to watch them. Thanks for watching my video on PID control. If you liked it, give it a big thumbs up. Make sure to subscribe and click the bell to get notified every time you post a new video. See you next time. Bye!